Hello, now I'm going to enter introduction. They got two methods for solve the equations. First one is bisection method. What's bisection method? The bisection method is a numerical technique used to find the root of a continuous function f x, where the function equals 0, i.e. f x equals 0. It is a simple and reliable method based on the intermediate value theorem, which states that if a continuous function changes sign over an interval, there must be at least one root in that interval. How to use it? The bisection method is a numerical technique used to find a root of a continuous function f x where f x equals 0 within a specified interval a, b. It requires that f a and f b have opposite signs, f a f b 0, ensuring the presence of a root in the interval. The method works by repeatedly halving the interval. The midpoint c equals a plus b 2 is calculated, and f c is evaluated. If f c equals 0, c is the root. Otherwise, the interval is updated to either a, c, or c, b, depending on which subinterval contains the root. This process is repeated until the interval is sufficiently small or f c is close to 0. The method is simple, reliable, and guarantees convergence for continuous functions. But it is slower compared to other techniques like Newton's method. Next I'm going to explain about simple fixed point method. What's simple fixed point method? The simple fixed point method is an iterative numerical technique used to solve equations of the form f x equals 0 by rewriting the equation as x equals g x. The goal is to find a point x asterisk such that x asterisk equals g x asterisk, which is called the fixed point of the function g x. How to use it? To use the simple fixed point method, start by rewriting the given equation f x equals 0 in the form x equals g x, ensuring that g x satisfies the convergence conditions e.g. g x 1 near the fixed point. Next, choose an initial guess x0 close to the expected root. Then, iteratively compute the next approximation using the formula xn plus 1 equals g xn. Repeat this process until the difference between successive approximations I xn plus 1 xi becomes smaller than a predefined tolerance. The method converges to a solution if g x is continuous and its derivative is less than 1 in magnitude near the fixed point.
Let's begin part B with bisection method. This is the question that we choose to solve. Given interval is 0, 1, and range is in 0.001. First, we need to define values VA and VB, and so we can get the value of VA and VB from interval. Then, draw a table. This shows how to calculate VM. Fill in the value of VA and VB in the table. Then, calculate VM for first iteration and fill in the table. Substitute VA equals 0 and VM equals 0.5 into the equation to get value of FVA and FVM. Calculate the tolerance error. We need to define value of FVM is positive or negative before proceed to second iteration. In first iteration, FVM is a positive value. So, we need to bring the value of VM in first iteration, which is 0.5 to VA in second iteration. And VB value is the same, which is 1 in first and second iteration. Let's see what step we need to do if the value of FVM is negative value in second iteration before proceed to the third iteration. We need to bring the value of VM in second iteration, which is 0.75 into VB in third iteration. And VA value is the same, which is 0.5 in second and third iteration. Continue calculate until value of tolerance error is less than 0.001. Then stop calculating. Since tolerance error when VM equals 0.575 is equal to 0.001. Therefore, the root is approximately V equals 0.575 volts.
The next method is simple fixed point method. Let's take a look at how this method works. First, we need to rearrange the equation first so that the equation will become Vn plus 1 equal to e power of negative Vn. Then, we should choose an initial guess. Let's say the initial guess is 1. Substitute the initial guess into the equation that we rearranged just now. We will get a new value for v. Next, we can find the error tolerance by using the equation in the slide. By substituting v1 and v0 in the equation, we can get error tolerance's value. Now, substitute the new value for v into the equation again. We can get the second new value for v. After that, substitute the second new value for v into the formula to determine the next error tolerance's value. Repeat step 5 and step 6 until the error tolerance is less than the range. We will get the voltage value which is as shown in the 13th iteration.
Analysis and conclusion. The bisection method is an iterative numerical technique that systematically narrows the interval via VB until the desired accuracy of is achieved. The method relies on finding the midpoint VM and updating the interval based on the function's sign change. The reliable method ensures convergence but requires multiple iterations, making it slower than other methods. The simple fixed-point iteration method is based on rewriting the equation in the form and using an initial guess to iteratively approach the root. The iterations continued until the error reached a sufficiently small value. This method converged efficiently but requires an appropriate initial guess for faster convergence. In conclusion, the bisection method is more robust and guarantees convergence but can be slow. The simple fixed-point method converges faster but depends on a good initial guess and the function's behavior. Both methods provided close approximations, with slight differences due to the nature of the iterative processes.